Let's talk about the Regula Falsi method, which is a mixture of the secant method and the bisection method. What is the problem? We have a function and we are looking for the roots of that function. And the idea is the following. The secant method is much better than bisection method, and it's also superior to the Newton method, not because the rate of convergence is higher, but because we need no derivative. So secant in the moment is the best we know, I would say. But there is a disadvantage, and we can study this disadvantage here in this example. If we have this function here and these two starting points, then the secant to these starting points is this one. This is the root. And now we drop x0 and take x1 and x2 to be the new points. And then we find the secant belonging to these two values. In this case, this will be the new x3. And after dropping x1, we get this to be the new x4. And having this x4, this is the secant and the root is outside. It's not really helpful to find this root, but the initial values were very good. They enclose the root, and one side with positive function value, one side with negative function value. And so there is a root. It's guaranteed there is a root, but we do not find. Using bisection, we could find this root, but convergence is slow. So it seems to be a disadvantage that the secant method drops the old x value and not like dropping happens using bisection. And so let's combine these two ideas. Okay, starting with these two values, find the secant, find the root of the secant, evaluate the function at that point, and then drop the point with the same sign. So in this case, we don't drop x0, but we drop x1. And then we have 2 points, and the function value is of different sign. A root between these 2 points is guaranteed, and we can iterate that process. And in this example, x3 is very close to the root, x4 is very, very close to the root, and it seems to be a very, very good idea. X4, having x4, we have the root, and in the example above, x4 is worse than x0 and x1 was. So it seems that the Regula Falsi idea is a very good one. And it's a very obvious idea. I think if there are 20 students in a room, at least one asks the question, why do we not combine them? And maybe you think, okay, it's of a didactical purpose. He wants to teach this and he wants to teach that. And at least me, I will combine them and get a better algorithm. So this is a very natural idea, but it is not true that this is a good idea, and we can study that. If you have a function which is convex, that means second derivative is positive, strictly positive, then this implies that every secant is above the function. This is the property of being convex, a convex function. So what does that mean? The point where the root is, the secant gives a larger value than the function. That means that the function value corresponding to that x is negative. So it's clear from the beginning this one will be dropped, and this will continue to be this way. So again, finding the secant is above the function, so the root of the secant is not a root of the function, and the function value belonging to that point is of negative sign, and so this one, x0, will keep being one of the points, and only the left point will be updated again and again. And it's more or less obvious that it's not a good idea to have a starting point which is not close to the root will be used over and over again. It should be also go to the root, otherwise it's obvious that convergence may be not as fast as it can. And here, this is not completely correct. You should better write causing the positive values of FA or FB to persist indefinitely without replacement. So either A will never be replaced or B will never be replaced. And we can analyze that. We will do that later in the next video in detail. But in this video, we analyze by studying some examples. Okay, we can formulate this is Regula Falsi, starting with A and B, and function values are of different sign. That implies multiplication of the function values is less than 0. If it's more than 0, then either both are positive or both are negative. So this means of different sign. And then finding the secant and finding the root. This is the formula for finding the root of the secant. We saw that when we studied the secant method. And then we drop either A or B. And that depends. We will drop the one with the same sign. What is the advantage of our Regula Falsi method? With suitable starting points, the method will converge to the root. At least this is the hope, and we will see in the example that it works. It's not, from mathematical point of view, not completely clear that it's true, but we will see that. Before we start, we need 2 starting points. And the user is the one who has to provide them. So this is an disadvantage, and we saw that disadvantage for all our algorithms. And the truth is that this is the last algorithm we will talk about. So none of the algorithms we discussed can overcome this point. This is a disadvantage, and the truth is it can't be overcome as long as we have some arbitrary function the user has to provide. Numerics is not able to find by himself appropriate starting points, and this is a big disadvantage. So don't forget that. This is one of the most important things I will say here in that chapter. You always have to provide them. The method can find only one root. If you want to find more than this single one, you have to start again the algorithm with appropriate starting values, and this is the truth for all algorithms. A disadvantage of Regula Falsi is that its rate of convergence is only linear, and secant and Newton is superior. Okay, so let's study for some examples the behavior. This is our algorithm. It's long, but okay, not so hard. It's a copy, it's a mixture of bisection and secant. If you understood these 2 algorithms, you will understand this one as well. So let's call for our example natural logarithm of x minus x divided by 3, there must be a root between 0 and 3. So let's start with these two starting points. And in this case, convergence is slow. You need 77 steps to find this root, and this is much, much slower than the secant method is. So regular falsi turns out to be not the best idea, although it seems to be a very good idea. Let's talk about our rope around the earth example. Then we can work with that function. We need the root of that function. This is the angle corresponding here in our problem. And let's start with these two starting points. And again, you need a lot of steps, but in this case not 77 steps, but 68,000 steps you need to find the root we are looking for. So regular falsi turns out to be not the best choice. And if we use again our rope around the earth, the other version with the tangent, then also you need a lot of steps, in this case 1,300 steps to find the root with the desired tolerance. So regular falsi is a good idea. It seems to be a good idea, but it turns out that it's not the best idea. When applying it, you get a slow rate of convergence, unfortunately.